Hello and welcome back to Self-Field Trainers. So in the last class, we dealt with column detailing. In this class, we'll be dealing with beam detailing. So for beam detailing, I have prepared a new Excel sheet like this. For a very long time, the students were asking me, can we have Excel sheet for beam also? So I have prepared one. So if you see here, as always, we have a 3D model like this, right? We have a 3D model like this. And after running the analysis and everything, I'm going to go to a plan view. Why am I going to the plan view? Because I have to do the detailing for my beams. Okay. So once I do that, you can see I'm able to see all the reinforcements over here in the area wise. Okay. So what I'll do is I'll convert these areas into percentages. So I'll go for display design info from here. And after that, I'll click on total rebar percentage. Okay. So I click on total rebar percentage, click on apply and click on OK. So what this does is it converts all the areas into the percentages. So if you see here, I have something called as 0.43, 0.22, 0.50. Okay, so I have 3 values on top and 3 values in the bottom. Okay, so we'll take this one as example because this is highest. I guess everything else is in 0.1, 0.3. So if I right click on this, you can see the beam name, that is B3, and you can see section B230 cross 450. If you go for details, you can find a lot more information about this. All right, but what do we need right now is we basically need the size, that is 230 cross 450, and the percentages. So coming to the Excel sheet at hand, the beam number that we have, I think it was B3. So we have to put B3 over here. Again, this green is basically for your Etabs value. This orange is for our input value. Okay. So this is the only thing that we're supposed to input. Rest everything it will get it on its own. If it is unsafe, it will come increase bar dia or number of dias. If it is safe, it will come as safe over here. All right. So if I open up a paint, I'll just draw a beam, a simple beam like this. Okay. And we have our, basically we have our columns. Just consider that we have our columns in both the sides. Okay. Like this. So what's going to happen is I've got 3 values on top, right? So I'll have at least 3 values coming up top and I'll have at least 3 values coming in the bottom. Okay. So this is nothing but top left reinforcement. Okay. So if I come over here, this is nothing but my top left reinforcement. Okay. Let me just decrease the size a little bit. Okay. This is my top left reinforcement. After which, if you have any extra reinforcement, I have provided a separate layer for that. Okay, so if you see here, extra bar. Okay, so we have top left reinforcement, we have top main bar, and we have got the extra bar over here. Okay, so something like this. This is the extra bar. After that, what we have, top reinforcement, top mid bar. So this is my basically top mid bar. That is going to go from one end to the other end. So this is my top mid bar over here. Okay, that is what I have mentioned here. Top mid bar, I have information over here. Then I have top right reinforcement. So I'll just come and type right over here, top right reinforcement. Okay. After that, if you see, I have given one more extra bar over here. If in case, if anything comes, you can just put it out. If there is no extra bar, just put 0, 0 over here. Okay. So I have one more layer over here. And in this layer, what I have mentioned it as extra bar. Okay. So this is what I have done. And then when it comes to the bottom reinforcement, we have got bottom left to right. So any other value that we have, we take the higher of the two values. Okay. So we have got bottom left and right, and then we have got bottom main bar. This is our bottom main bar. Generally, bottom main bar will have higher value. Whatever reinforcement we get for bottom main bar, we just write it here and there. Okay. If some extra amount of reinforcement is required, we'll just go and provide the extra amount of reinforcement over here. Okay. So for bottom reinforcement, I have given extra bar here. Okay, top main bar, this is bottom main bar is this going from here to here. Now why is this happening? If I have to explain it simply, it is because the deflection diagram, how the deflection diagram will look. If this is our normal beam, it will deflect something like this. Okay, so what happens, we have a tension zone and compression zone, right? So wherever tension zone we have, this is our tension zone. Okay, this is going to be the bottom. We have a tension zone. So same tension zone will be in this area also, but near the support. Okay. So I'm just put it over here, tension zone. And one more tension zone will have where? We will have it over here. So wherever we have tension zone, there we have higher amount of moments, because of which extra bar might be required. So where in the top, here and here. Okay. So that's in the 3 places I'm providing extra rebar if it is required. If it is not required, I'll put 0 and 0 over here. So hope you have understood. Top left reinforcement is this. Then extra bar we have provided for that. Then top reinforcement, we have top mid bar over here that runs from one end to the other end. Then we have top right reinforcement over here and extra bar. Again, if you see, I have given 0, 0 here currently. So even if the value is low, we don't have to provide an extra bar over there. If the value is high, if the this amount of reinforcement is required, only then you're supposed to provide the extra amount of rebar over there. In the bottom, we have bottom main bar, and any extra bar it is required, we'll provide. Now, even I explain why we provide extra bar, because of the tension zones. Okay, in the tension zone, what basically happens is we have higher amount of moments, because of which to counteract those moments, we have to give higher amount of reinforcement. Okay, so I hope you have understood. Let me minimize this and we come to our Etabs file over here. So in the Etabs file, if you see, we have columns here and here, and if you see the values, okay, let me just take this to one corner over here. I'll just bring it over here like this. Okay, so I hope you have understood what is top left reinforcement. This is my top left reinforcement, right? So what I have to fill, I have to fill these values. Before that, I have to fill the B and D value. So what is my breadth? I think it was 230 cross 450. Let me cross check once. 230 cross 450. So I'll open this. I'll mention this first, 230, and then that is 450. Okay, after that, what I'm going to do, I'm going to fill all these values. So top left reinforcement is 0.43 for me. So 0.43, enter. Okay, as you can see, increased bar dia or number of dias. Then we have top reinforcement, 0.22 we have. So I have to provide 0.22 over here. Then in the right side, we have 0.50, 0.50. Okay, so as I was saying, because we have tension, what is happening here? We have higher amount of reinforcement requirement. In the bottom, if you see, we don't have any higher amount of reinforcement requirement. Same thing goes to the top also. It is 0.22 only. After that, top right reinforcement is done. Now I have to come bottom reinforcement, bottom left and right. Left and right, we have to see the highest value in this. Highest is 0.25. So I'm going to take here 0.25. Okay. And then bottom reinforcement, 0.69 we have. So I have to put 0.69 over here. If you want, you can put 0.70 also. Okay, no problem. So you can see here, everything is filling. Increased bar dia or number of dias is what the message is telling you. Okay. So now what I have to do? I have to input these values now. Okay. So if you see here, I have mentioned the steps over here. How you're supposed to input in this given Excel sheet. So first you'll put 1. Okay. Now what is 1? Top mid bar. Okay. This is my top mid bar. That is going to run from here to here. Okay. So I have to satisfy this condition first. So I have put 2 of 12. And what is happening? It is failing. Requirement is 0.22, and what we have provided is also 0.22. But the problem at hand is that we have to provide just a little bit extra over here. Okay. So what I'm going to do is I can make it 3 of 12. Let me see what happens then. It is just a second. Let me make 3 over here. Okay. It is coming as safe. Okay. 3 of 12. It is coming as safe. Now what I have to do? I have to change this also. Right. Top main bar. 3 of 12 is there already there. Okay, and if you see, because of what I have input here, I can just copy and paste this over here. 3 of 12 already is the top main bar. Extra bar I have to provide because 0.33 is the AST provided. Our requirement is 0.43. So I'll go for 12 and I'll try to provide one more extra bar. Okay, it is coming as safe, but what is going to happen is it is 230, right? So the kind of reinforcement that we're going to have is, if you see in the view, so we have got a representation like this. This is basically our cross-section view. So in this, what is going to happen is we have to give some amount of offset and everything, and then we'll have our remaining size. In this size, what's going to happen? I have to put 3 main bars like this. When you use the circle. Okay, so one bar will come over here, other bar will come over here, like this, and one more bar will come like this. Okay, 3 bars are coming like this. Then I have to provide one more extra bar, right? So where will I put that bar? No, I cannot adjust one more extra bar in the corner here because the spacing between the bars will become too small because the width is 230. And then I'll already lose 40 from here and 40 from here. So it will become too crowded. Okay. So what I can do, instead of providing 3 of 12, I'll provide 2 of 16 over here. Okay. Just bear with me for a second. Required is 0.22, but we're providing 0.39. Okay. So that we can satisfy the corner part also. So I'll make it 2 of 16 over here also. All right. And then what I'll do, 1 of 12, we can provide in the middle. Okay. So to make sure that we have enough amount of reinforcement, because you cannot keep cutting the bars and lapping them. That is not how it works on the side row. You have to run one same bar from one end to the other end. Now the reinforcement of the left and right is more compared to the mid part. Okay. So additional amount of reinforcement will go by default to the mid part. All right. This is you cannot break the bars and keep lapping them in the beams. Okay. It will become a bit difficult on the side for you to keep doing it for each and every beam. So some additional amount of reinforcement will go for this particular mid portion. Okay. So now what happens, instead of having a reinforcement, it will be same thing only, but now what will be the case, in the middle we'll have 16, in the end we'll have 12. Sorry, we'll have 2 of 16, in the middle we have 12. This will be 16, this will be 16, this will be 12. Let me just change the colors for them. For example, let's just fill the thread. Okay, so this is going to be our 12, the other two will be 16. Okay, so 2 of 16, 1 of 12. In the middle we are providing additional amount of reinforcement so that it satisfies the more amount of reinforcement for the end parts. Okay, so now top reinforcement again 2 of 16 I have to provide over here. By default I have to provide 2 of 16, so required is 0.5, providing is 0.39. Let me try 1 of 12 and see if it will hold up or not. It is not holding up, so I'll make it 1 of 16 over here. Okay, little extra amount of reinforcement is fine for on the safety end. All right, so what have we done so far? We are initially given 12, but as I showed you over here, it was not possible for us to put all those bars here. All right, so what did we do? We made it 16. Now 16 is satisfying both this end and this end. So some additional amount of reinforcement is going in the mid part. Okay, so 2 of 16, 1 of 12 for the left hand side. Okay, if we can see here also, just a second, let me minimize this. So 2t of 16 is there, 1t of 12 extra bar is what I'm providing here, and 1t of 16 is extra bar I'm providing over here. Okay, now come to the bottom part, and if you see here, this is the fourth. Okay, so bottom reinforcement, main reinforcement will provide first. The requirement is 0.7. Can I make it 16 of 2 and see what happens? 0.34 we are getting, so I'll provide 2 of 6 extra. Okay, so getting 0.78. Okay, so what I have done, I have provided 2 of 16, 16 not 12. Okay, it is taking the top part, that's why it's the main bar. Okay, okay. So in the bottom, one bar is gonna go from one end to the other end. Bottom main reinforcement, okay, is going from one end to other end. Then 2 of 16 I'm providing on the top. Okay, now if I make it 2 of 16 over here also, by default, what happens? It will become as safe. Okay, required is 0.25. We are providing 0.39. Why are we doing this? Because as I mentioned, you cannot keep breaking the rebar and keep lapping it to make it efficient. Some places will end up providing a little more extra than what is required. Okay, so requirement is 227, you're providing 402. Requirement is 570, you're providing 603. Requirement is 250, you're providing 402. All right, as I explained already, this happens because we cannot keep lapping everywhere in the beam especially. Okay, so I hope you have understood the top part. So what did we do? We took 0.43 top right, then 0.22 top mid, then we took 0.5 top right hand side, then we came for the 0.25, that is highest of these two values in the bottom, then we came for mid part, that is 0.69, we made as 0.7, we just rounded up the value to 0.7. After doing all this, I first input the value in this particular top reinforcement mid part, and what happened? We got 12 of 3, but as I showed here, it was not possible for us to fit all the rebars in given space. Okay, so what did I do? I went to the other end, top reinforcement, where the more amount of reinforcement was required, and I gave a 2 of 16 and 1 of 12 and it was safe. So I copied the same thing from here and I pasted it to the top mid bar. Same thing I pasted to the right hand side also. And here if you see, extra bar required is 1 of 12, extra bar required is 1 of 16. Okay, this is how you're supposed to keep doing your reinforcement for each and every beam. Alright, that's why using RCDC and everything will make your work easier, because RCDC in the backend will do all this for you. But many people are not using RCDC. They use Autocad or they use Revit. It's up to them. Then we came for the bottom reinforcement. Okay, bottom left and right. We took the highest value of bottom left and right, and 2 of 16 was satisfying it. And even here, if you see the mark over here, what I filled first, I filled the bottom reinforcement, bottom main bar I filled first, because higher amount of reinforcement requirement was here. Okay, so 2 of 16 I put, 2 of 16 I put, this became safe and everything is safe now. Alright, so if you see the rebar arrangement, how it will be, we'll have 2t of 16 running from one end to the other end. Then on one side I'll have 1t of 12 extra, other side I'll have 1t of 16 extra. In the bottom, 16 bar will run from one end to the other end. In the middle I have 2 of 16. Okay, then next part comes our this value. So if I, for example, if I make it 400, this is our shear reinforcement. Okay, so ASV by S is the formula for our shear reinforcement. S is spacing, okay, tie bar spacing. ASV is the area of tie bar into number of legs. In generally what we do in our this one is, if you see here, the space is hardly how much? 200 mm. Okay, in that I'm already putting 2 to 3 bars. So here I don't have to make it 4 legged. Okay, again it's up to you. If you have a very wide beam, we'll end up making 4 legged also at different points. Okay, but I'm going with 2 legs only here. Okay, I'm going with 2 legs and I'm going with 10 mm dia bar for tie-up. I can go for 8 also, no problem. So if you see, it will become 225 spacing. Okay, so let me come to the problem here. Let me go for this option, go for display design info. Here I'll go for total rebar percentage. I'll go for shear reinforcement now. Click on apply and I'll go for click on OK. Now if you see, the 1071, 1015, 1028, very high values these are. It's okay, no problem, because moments are also high. I'll go for 1071 value, okay, because there's the highest of the 3. So I'll come over to the Excel sheet, make it 1071 over here. Okay, so ASU by this will become like something like this, and we can see the spacing that I'm getting only 75 spacing. That is actually very small. Okay, minimum 150 should be there, because just imagine you putting tie bars, okay, ties at every 75 mm interval. How much amount of steel you'll end up using? A lot, right? Okay, this will make your execution very expensive. It will increase the cost of the project. So to avoid that, generally what do we do is, in a mid part, the spacing is at a very good distance from one another. Okay, sometimes they go for 200 also, sometimes they go for 250 also. Okay, but as and when the extra bar and all comes, they start placing everything very closely, like this. Okay, generally we have zone A, we'll divide this whole thing into 3 zones and we work with it. Let's not get into all of that right now. Okay, so what generally happens here is 1071 is my requirement. Okay, I have converted mm square per meter to mm. Now what I can do is, instead of making the 75, I want to increase the spacing so that my cost of my production goes down, construction goes down. So I'll make it 10 dia bar. Okay, 10 of 2 leg. We can see the spacing is 125 mm center to center. Alright, again we have some conditions in IS 456 about the spacing only. That 16 times of minimum bar size should be there. Minimum bar size I think is 16. Okay, so minimum bar size I'm going for 16. Don't consider the extra bar. Extra bar is only one side. Okay, and I'm taking the highest of all the 3. So 16. So 16 times bar size 256 will get. Okay, then we have 300 mm least. Then least lateral dimension that we have is 230 mm over here. So okay, it has to be the least of these 3 and the value that we have got. Okay, so least of the 4. So if you see, we got 146 here. Alright, and this 146 I have rounded it up to the 25 mm mark, so 125. Some people, what they will do, they have got 146, okay, we'll make it a 150 also. Okay, why? To save cost, because steel is very expensive. Alright, so I hope you have understood what we have done here. Okay, shear reinforcement, what we have done, I have taken the direct value from here, highest of the 3 value, I have input that value over here. After which I have assumed my dia of tie bar as 10 and number of legs as 2. Okay, after that the calculation is given here. ASV is equal to area of tie bars into number of legs. So ASV is equal to basically this value into this value. Okay, pi d square by 4 into number of legs, I'll get this value. Okay, after which what I'm doing is, when I come over here, you can see basically exchanging of the values. Alright, so spacing I'm getting how much? 146. This 146 mm spacing which we have, this spacing will get compared against these 3 values from the code book, 256, 300 and 230. The least of these values will come over here. After that what happens, we have to round up this value, and I have rounded it to the 25 mm spacing. So I've got 125 mm center to center as my main value over here. Okay, so I hope you have understood how this works. Watch the video 1 or 2 times, because beam reinforcement is not as simple as column reinforcement. Okay, some amount of side knowledge is required from your end to make all these changes. Okay, as I said, on the side it is not possible for me to put 3 bars and then 1 extra bar somewhere in the corner, somewhere over there. I can't do that, because the same bars will run from one end to the other end. So what I did, I changed it to 16 of 2. Even though in the mid part what is going to happen, some additional amount of reinforcement is there. And again, don't think this is going to be over reinforced. That is not the case. It is not going to be over reinforced just by increasing the value in the mid part. Okay, under reinforced only it's going to be. Alright, so it is not going to fail in what? It's not going to fail in sudden failure, because it is under reinforced. If you make it over reinforced, yes, then what happens? It will go under sudden failure also. Okay, so I hope you have understood. If you want this Excel sheet, how you can get this Excel sheet from our course, in the Etabs, Safe and RCDC you can find, or in this main combo course also you can find the same thing. And if you take up this course, what is the USP of this course is, we have done one project start to finish. Okay, right from you getting the grid line marking, everything in Etabs, until what? Until column submission also. Column submission drawing, beam submission drawing, slab submission drawing, footing submission drawing. The drawings that you submit to your client. Okay, so it is not just Etabs course. It is a complete design course. Etabs, Safe and RCDC. All 3 elements will be used in this. So if you're interested, check out the content. I'm giving 500 coupon code on this. This is the only course in the market that I believe at this price point that will teach you how to create drawings and submit them. Okay, many people just teach you Etabs, many people just teach you safe, and they just leave you. That is not the case. That is not how you get paid on the site. Okay, if you want to get paid, you should know how to create drawings. All right, only then that's going to work out. And again, if you're going for a job also, you should know something extra than the other person. If the other person knows Etabs and safe, but you know RCTC also, that can greatly benefit, that can greatly increase the efficiency of your work. Of course, you're gonna get the job compared to that person. Okay, it is not simple as that, but again, learning and having good backing from software is very essential for you to crack a good job. So with that being said, thank you. I hope you have understood. I think it will take you 1 or 2 tries for you to understand this video, because this adjustment you should understand why we have made this adjustment. Even if some extra amount of reinforcement is going, we are providing it anyway, but to be on the safer side. Okay, so that's all for this class. See you guys in the next class. Thank you.